My name's Roger Wachter. I'm the general manager and co-owner and founder of EGS Systems, located here in Târgu Mureș, Romania. Today we're going to produce a video tour of EGS facilities, and we'll be taking a look at some of the internal processes and manufacturing capability that EGS Systems has, which has driven EGS Systems to be a market leader in the packaged gas compressor market, serving former Soviet Union or CIS countries, European Union, Middle East, Africa, and Asian gas compression markets. One of the things that have led us to be a market leader in the natural gas compressor industry is our focus on customer satisfaction, which comes from not only delivering to the customer quality products and on an on-time basis, but also following that product to the field and making sure the customer is properly supported from an aftermarket standpoint. During the tour today, we are going through the hallways of the office so that you get an idea about the office layout, the type of people that we have employed here. The cycle for delivery from a customer from contract signatures actually starts with the engineering department. And during the time that the engine and compressor, which are built in the United States, are being manufactured by those equipment manufacturers, the engineering cycle is going forward at EGS Systems. As an output from the engineering is the bills of material, all the bill of material that will comprise the packaged product, the final product as it's shipped from our facility. Okay, so let's go ahead and start the tour today. And in the course of the tour, you will be able to meet some of the other managers of EGS Systems. So, I'd like to introduce everybody to Mr. Claudio Orban. He's our sales director from EGS, and Claudio is going to tell you a little bit about his team that he has that's working hard to sell the equipment that we produce.
Part of the department that I'm running, I got 4 sales managers, each covering a certain region, one dedicated for the CIS market, Europe, Middle East, and Africa. Together with that, I'm running a team of application teams consisting of 4 engineers. Here's where the magic starts. All the inquiries are coming and channeled through the application department, which put together the customized offer for our customers.
My name is Mircea Bogdan. I have joined EGS about 8 years ago as an application engineer, and starting last year, I'm in charge with the application department. What can I say about the job in EGS is the fact that you are facing challenges every single day, and the most important part is the fact that you learn everything.
My name is Nikita Matin. I'm regional manager for CIS countries in former Soviet Union, which is Russia, Ukraine, and Belarus, our active markets. And I'm happy to be with EGS for the last 7 years. And within these years, we made a great efforts and great success on these markets together with EGS products and our approach to the market requirement.
Hello, my name is Elena Maria Togan. I'm in charge of production, design department, warehouse and logistics. EGS is a great place to work where you face a lot of challenges every day. Very nice team of people. I feel I'm motivated to do a good job. I hope I can inspire people around me.
Hello, my name is András Pupa. I am the engineering manager at EGS Systems for 11 years, and I supervising 7 package engineer and 3 automation engineer. We use 3D environment, especially Autodesk Inventor for 3D modeling. For process calculation, we use for Cooler HTRI software and visual vessel design and PV Elite.
I'm Lucian Vancea. I'm a design engineer. So we have a 2-skid modular unit. It contains of a 3-phase separator skid, which separates oil, water, and gas. Also we have 2 pumps, which circulate the water and the oil. The compressor gas then goes to a compressor skid, which contains of a 3-stage engine-driven compressor. Also we have an engine-driven cooler, which cools the gas, and the water, which cools the engine. The gas goes back to the 3-phase separator skid, where it either goes to export line or to gas well to use the high pressure as a gas lift. So from all our sub-assemblies, from the cut system, we automatically send it to the ERP system, and we make sure that all our materials are in time for the manufacturing process to begin, and we don't have any shortages of materials.
Hello, my name is Marcel Sokol. I work at EuroGas Systems as a project manager supervisor. My main focus here at EGS is to keep the relation with the client so the project goes very smoothly. In the past 10 years, I've seen EuroGas Systems as a company growing year by year.
Hello, I'm Ervin Shorter. I'm the procurement manager of EuroGas Systems. I joined the company back in 2018, and we are a great team here, so it's great to be a part of.
Hello, my name is Cristian Helese. I'm the production manager of EuroGas Systems. I'm working here 9 years already. I am in charge of the entire production process. My job is to deliver nice products in the right time with the good quality.
Hello, well, my name is Kirila Alexandra Maria. I am the aftermarket sales manager for EuroGas Systems. Our main job is to take all the inquiries and all the needs for our customers that have needs for spare parts. I would like to say that I am very, very happy to be part of this EGS team, which has been my family for 10 years. Happy to improve and evolve and grow along with it, and I hope for the best yet to come for EGS. Thank you.
My name is Răzvan Gheorghiță. I'm planning and system manager here at EGS. I've joined EGS 5 years ago, and since last year when I was named as planning manager, I'm working more closely with the design, procurement and the production to meet our client requests and schedules.
Okay, next stop on our tour, we're in the office of the commercial director, and I'd like to introduce you to Lala Wachter.
Hello, I'm Lala Wachter. I'm commercial director for EuroGas Systems. In other words, I could say I'm a contractual manager because I am responsible for reviewing the contracts, to prepare the contracts, also to follow up with the terms to be sure that all our requirements and obligations are fully implemented in accordance with the contract. So I hope my experience is really helpful for EGS, and I see how EGS really quickly and professionally growing, and I believe sure all team is feeling like a family and fully involved and caring about how we grow and how we present it in the market.
Hello, my name is Jana Müller and I'm Administrative and Financial Manager at EuroGas Systems. As Administrative and Financial Manager, I have 3 departments reporting to me: HR department, Financial department and Administrative department. I'm very proud and it's an honor for me that I had the opportunity to work in this company with these people and the management. I have a lot of things to learn from them.
My name is Alina Strete. I'm Chief Account in EGS. I organizing and coordinating all the department of financial accounting. I'm very proud to work in this team.
My name is Ioana Laura Mariș. EGS is for me my second home. I'm glad to work here with such a team. EGS is a big family, a great team.
Hello, my name is Teodora. I'm the logistics manager of EuroGas Systems. I handle all shipments that are coming from Europe, outside Europe, also the exports all around the world. It is a big challenge to be here. We learn new things every day, so I'm very happy to be here.
My name is Ioana Iliescu. I run the quality department, but it's actually officially named HSEQ. It covers health and safety, environment and quality, and they are all important. I run this department together with 2 international welding engineers, 3 quality controllers, a non-destructive testing laboratory, and some quality clerks. What we are actually doing here, we are making sure that the foundation of this business stays as strong and compliant with the rules, because we are working in a heavily regulated field of activity.
Next, we're going to start the shop tour, and where we are starting here is in what we call Plant 2, which is our assembly plant. So as you can see, our assembly plants broke up into 2 assembly bays. We're right now in assembly bay 1. And then you can see on the other side of the center beams there's another bay which we call assembly bay 2. Each of the assembly bays is fitted with 2 50-ton cranes and 4 10-ton cranes. So each 50-ton bridge has a 10-ton auxiliary, and then we have 2 separate 10-ton bridges. The height of those cranes, the hook height is 13 meters or about 50 feet high when the crane hook is all the way to the top. So we have a purpose-built, very large and tall building to do the assembly work of the products that we build. For a size perspective, the assembly plant here is 160 meters long, which is about 500 feet, and each assembly bay is 15 meters wide, which is roughly 50 feet in width. We're still in assembly bay 1, and right now we're standing inside the shot blast booth. Of course, the shot blast room here is used to clean the steel components before we paint them. And to give you a size perspective, the shot blast booth is 4.5 meters wide and 15 meters in depth. Each of the assembly bays has its own dedicated paint booth. The paint booth in assembly bay 1 is 4.5 meters wide and 15 meters deep. And the paint booth in assembly bay 2 over here is 7.5 meters wide and 15 meters deep. Okay, right now I'm standing inside the paint booth of assembly bay 1. As you can see, and as I mentioned before, it's quite a large paint booth. So for most of the assemblies that we build, we paint the assembly component by component and then do final assembly and touch up after the assembly is complete. Now we've moved inside of the paint booth, a much larger paint booth over on assembly bay 2. And as you can see, as I mentioned before, these are typically used by using these large racks with these big hooks on them to hang pipe runs and component pieces for paint prior to the final assembly. And then after assembly, it's just touch-up work from there. On one of the carts here, you can see a gas separator that's been built and at least primer painted at this point, ready for its top coat. Next door to the paint booth here is the hydrostatic test area. So as you'll see in here, we have storage tanks up in the top of the test area where we store the test water for hydrostatic testing. That test water is gravity drained down into the vessels that we're testing. At the completion of the hydrostatic test, we just simply pull the plugs out of the vessel that's being tested or the pipe that's being tested, drain the liquids, the test liquid back onto the floor, which gets pumped through a filter system back up into the storage tanks. By doing this, it serves 2 purposes. One, we're not dumping test water into the storm drain. We're recycling the test water. And secondly, when we drain the vessel or the piece that we're hydrostatic testing, the coolant, which is actually CNC machine coolant that's mixed with the test water to control the water quality, that coolant leaves a very thin coating on the inside of the vessel that prevents it from rusting. So it's a rust preventative or preservative after the testing process. And next we're going to start walking down through the shop and take a look at some of the product that's currently being built in this plant. So on the pallet here, you can see a couple cooler headers, which will eventually become cooler sections, because in between those 2 cooler headers, we'll put finned aluminum tubing in there that'll do the heat transfer process. So this is part of our air-cooled heat exchanger product line. Up here on these stands, you can see a cooler header already assembled to the side plate. Next on the floor here is a typical, what we call E-style cooler structure. So the concept of air-cooled heat exchanger, we have big fans moving air from top to bottom. The air is a cooling medium that blows through the cooler section. The medium to be cooled, whether it be gas, oil, or water, is inside the tubes, moving back and forth through the tubes, and the ambient air is flowing over the tubes to perform the cooling process. Moving down the shop a little further, I'd like to talk to you a little bit about this machine that's sitting here. So over the next few minutes, as we tour the shop, you'll see quite a bit of CNC equipment that EGS has been investing in. And the first CNC equipment that we'll look at right now is a very large CNC mill. And I'd like to open this mill up so you can get an idea how big the table is. Okay, so again, this is CNC. All of our CNC equipment that we've been investing in is operated using a Siemens CNC control head. This is a large horizontal and vertical milling center. So what we happen to have sitting in the mill at the moment is a module that a compressor and a motor will be eventually mounted to. So we use this large mill to plane the surface of the module to give a flat space for the compressor and the motor to mount to, and also go in and do all the drilling so that all the tie-down bolts for the motor and the compressor will be in exact positioning to give us clearance around the bolt and to give us flexibility for alignment. The size of the milling table that's sitting here is approximately 4 meters long and about 2.5 meters wide. But that doesn't mean that's the constraint of what size piece that we can mill, because we can actually overhang the table by 1/3 of the distance on each end. So that means we could mill a piece that's roughly 7 meters long inside this mill. And as far as milling height, we can mill the top of our tallest compressor module, which is about 1 meter in height from the table. So this is one of the largest, in fact, as I understand, it's the largest mill of its type here in Romania. Continuing down Assembly Bay 2 here, there's some fairly large compressor sets on both Assembly Bay 1 and Assembly Bay 2. There's actually 6 machines here that are color code painted. There's 2 small horsepower electric drives, 2 kind of I'll call medium horsepower, and 2 large horsepower electric drive machines. Walking back over to Assembly Bay 1 here, these are the 2 smaller electric drive compressors that I was mentioning moments ago. And these are, as you might be able to tell, they're single stage electric motor driven compressors. But these are for a customer here in Romania. They have full automation on them, and they're also VFD controlled. So as you look at the amount of piping that's on these compressor units, for a single stage gas compressor, there's a fairly significant amount of piping installed. Partly because there's shell and tube gas coolers that are mounted onto the packages. So the green pipe is for the water piping that serves the cooling as a cooling medium for shell and tube coolers. All the yellow pipes are for processed gas. Okay, we're still in Assembly Bay 1, and we just got through looking at these 2 smaller horsepower compressor packages. And next I want to point out the next unit on the floor here, which is also a single stage gas compressor packaged in a very, very similar, almost the exact format of these smaller horsepower ones. Again, with a lot of valving and a lot of automation. Walking back over here to Assembly Bay 2 again, over here across the aisle is the sister unit to the unit we just looked at, the large horsepower single stage compressor. And then further down the shop here, we're going to look at a couple of what I referred to as the medium size electric drive. The difference about these compressors down here is that you can see by the piping design, it's set up as a 2-stage gas compressor, where the smallest ones and the largest ones were in single stage configuration. One of the things I like to point out while we're taking this tour is EGS uses very high quality componentry on all of our gas compressor sets. And a prime example of that is the pressure transmitters and the temperature transmitters you see installed on this gauge rack. These are standard, our standard transmitter is made by Emerson Rosemont. Some of the companies that I've worked at in the past, and many of the competing companies to our company, will not use Emerson Rosemont as a standard offer. So Emerson Rosemont is a big upcharge, an adder cost to move up into the top of the transmitter world, if you will. So, but at EGS here, that is our standard. So we don't quote something of lesser quality. Moving down Assembly Bay 2 here a little further, the next two units in line here are the medium size electric drive 2-stage gas compressors. And again, you can see that it's in a two-stage configuration, because you see a gas separator for each cylinder that's on this 2-throw compressor. So you've got suction on the far side with its own separator, suction separator, and then it goes through the cooler and then comes back to the interstage separator here, and it gets compressed again in the smaller cylinder and then gets cooled one more time, and then it goes through the discharge coalescer that you see here in the middle of the skid. Just moving down Assembly Bay 2 a little further, the next unit here is the sister unit to the one we just talked about. Again, medium horsepower 2-stage gas compressor. Same design as the one we just reviewed a few minutes ago. The next couple units or couple skids that we're going to take a look at here are the skids that we looked at earlier today in engineering, when Luchan was sharing with us his computer screen talking about the 3D models that he was making for the gas compressor unit. And then the second skid had the 3-phase separator with the separate fluid pumps on it. So the first skid here is obviously the gas engine driven Caterpillar gas engine driving a 2-throw aerial compressor. It's set up in a 3-stage configuration like Luchan had mentioned. So there's two different possibilities for the gas outlet here. One, it would go to the sales line, as Luchan said, or secondly, they can divert the gas flow back to the well and re-inject that gas and use it as a gas lift for a gas lift process. Continuing down Assembly Bay 2 here, we just looked at the gas compressor skid that Luchan showed us earlier today in engineering. And this is the second skid that Luchan had pointed out to us on his computer design. So here in the middle, it'll be mounted a large 3-phase separator. Here on the end of the skid, see the liquid pumps. One will be, after we do the 3-phase separation, we'll take water out separately from oil. One of these pumps will handle the water. One of the pumps will handle the oil flow. And then the gas coming out of the 3-phase separator will actually get moved over to the compression skid. Just moving down the shop the rest of the way here, what we have at the end, you can see over here on the right side, some cutoff saws. Down the big gray machine at the end of the shop is a 400-ton press brake, which again is a pretty large capacity press brake for a steel fabricator like we are, or a fabrication shop. And over in the right-hand corner there, you can see an inset, and that's a small machine shop area. Across Assembly Bay 1 over here, you can see we have a high-capacity warehouse. So our upstairs offices ends 30 meters short of the building, so there's 30 meters of warehouse space there that go all the way up to about 12 meters in height. We just left Plant 2 assembly plant, and we walked over here to Plant 3 vessel plant. And on the way, we passed the NDE laboratory. And that NDE laboratory was built in 2014. And from that laboratory, we do all forms of non-destructive examination, including VT, PT, MT, UT, and RT. So we have the licenses from the Romanian nuclear authorities to own, store, and transport the radiographic source for making radiographs. And we have 3 technicians fully certified in all forms of NDT to do our own in-house NDT and also externalized NDE. So since the lab's been here, we've had a growing and more, we've been growing our customer base for externalized NDE work. Okay, right now we're inside of Plant 3. which is our new vessel and steel fabrication plant. This plant was commissioned early last year, and the purpose of this plant was to build a larger and more modernized plant for the fabrication of pressure vessels and other steel structures. Part of the investment and the tooling that has gone into this building is that first step is we put a 4-roll plate roller over here in the corner. It's made by Davi Corporation in Italy. It's one of the leading plate roll manufacturers in the market today. And by having 4 rolls on our plate roll, we're able to do a pre-bend on the plate before we roll it into a cylinder to become eventually a vessel shell. By doing the pre-bending, capable by having the 4th roll, it allows us to minimize the flat spot in the shell where the vessel shell comes back together in the shape of a cylinder. So this is a fairly large capacity vessel roll. We can roll up to 3.5 meter diameter shell with that machine and up to 63 millimeters thick. Another investment we made, because we had a sub-arc machine that we can look at here in a minute, but we've invested in a much larger column-based sub-arc machine, which is over here on the right-hand side. So this is an air liquide machine, fully CNC controlled, as is that Davi plate roller. So I'd mentioned earlier that we invest more and more in CNC controlled equipment. So we have a CNC controlled Davi plate roller, CNC controlled column mounted sub-arc machine. And these machines were again bought for the purpose of moving up into a larger vessel diameters for not only our compressor packaging efforts, but also for expanding our business into gas processing equipment. Another big investment we made is this 5-axis, CNC-controlled 5-axis robotic plasma and oxyacetylene cutting center. So this cutting center is set up to cut 3 basic products. The first one is for cutting vessel shells. So if you could move down this way and take a look, this is the shell cutting area here. So we have a large 4-jaw chuck that actually grabs the vessel and will turn the vessel from a CNC controlled cutting path, and then the plasma cutter will come down and cut the holes in the shell, and while keeping track of the orientation of the shell within 0.1 millimeter. So with this CNC controlled machine, we've added a lot of extra quality and accuracy to our vessel cutting, and we've greatly reduced the time it takes to lay out and cut openings in a large diameter vessel shell. So this machine, as it's sitting here now, will cut in a CNC format up to 2-meter diameter vessels and up to around 8 meters in length. So again, all for the effort of moving up into larger diameter equipment for both the gas compression industry and for gas processing equipment. The second shape that we can cut with this new plasma cutting center, plasma oxyacetylene cutting center, is cutting shapes on a 5-axis format, cutting plates and domes meaning the closure of the pressure vessel. So this table sitting here in this portion of the machine, we would lay a plate on it and we can cut that. So we can cut beveled plates in one cut, because the machine's working on a 5-axis in a 5-axis way. And then we could put a dome on here or a pressure vessel head and cut the openings in the head for nozzle connections in the end of the pressure vessel shell, or end of the head. So this is kind of the smart part, if you will, of the plasma cutting center. You can see that there's 3 stations here. The first station, marked Z1 at the top, that is for oxyacetylene torch. Station 2, marked Z2, is a scanner, and Z3 is the plasma cutting torch. So one of the great advances in this type of equipment today is the scanning technology. So when we put a pressure vessel dome on there to cut the shape, or we put an I-beam, and I'll show you that here in a moment, how we cut beams, but any of these product configurations have a fairly loose mill tolerance when those product types are made. And for a plasma cutter to make a very accurate, precise cut, you have to control the distance between the cutting torch and the workpiece. So the first step in cutting a dome or an I-beam is for Station 2 scanner to go in and actually scan the product. So now the machine knows exactly how what the configuration of that component is, not just what the theoretical dimension is based on the mill tolerance or the mill industry. The third product type that we can cut with our new CNC controlled plasma cutting center is I-beams or H-beams. So in our business we use a lot of I-beams and H-beams to build structural steel skids that our compressors are mounted to. And it's very time consuming to cut and cope the beams to intersect with each other on a 90-degree angle. But with this investment in this plasma cutter, each beam end will be profiled by the machine using a plasma torch. And one of the most impressive parts about the entire equipment is that everything we saw earlier today being modeled in our engineering department in our 3D modeling system, our engineering system, will be fed through internet to this machine through CAD/CAM software interface. And one of the great parts about that is whatever we've modeled in engineering as their final product configuration will be sent directly to the machine, and there will not be a human interface where somebody's in the shop entering information into a CNC controller. So it takes the human element out of the interface between our CAD system and our cutting path, or our CAM operation down here in the shop. So the CAD/CAM interface through software is a very, very important part of this investment to ensure that we make high quality cuts, minimize the amount of error that's possible in even making the setup, and then also greatly reducing our manufacturing time for cutting the raw materials prior to welding. Also located in here in Plant 3 is another CNC mill. This mill is most frequently used for machining the headers for gas coolers or water coolers or air-cooled heat exchangers. But I'd like to point out how much smaller this mill is compared to the one we have over in our compressor assembly plant. So this milling table is about 80 centimeters by, I don't know, 2 meters, 1.8 meters in length. But this mill in itself, it's also CNC controlled using a Siemens controller, as I mentioned before. But this mill is large enough to build or to machine almost any cooler header that we would actually need to build for a gas compressor package. If we get into larger size cooler headers, like for gas transmission, pipeline transmission coolers, we now have the larger CNC mill capability over in Plant 2 that we can put larger, heavier headers on, which gives us a full range of capability for very large air-cooled heat exchangers as well. So we're pretty much done with the tour of Plant 3 here. The rest of the equipment that's sitting around us in this shop is some of the early equipment we bought back when we started the company. And we had our startup facility in what we call Plant 1, which is now turned into a warehouse facility. But that welding equipment, cutting equipment has been moved over here. And over on the right side here, you can see some fairly large welding booths. On the left side, you have some more of the same. We have a machine lathe here, other equipments that you would typically find in a well-fitted pressure vessel shop.
My name is Diana Mailet. I'm the marketing person here at EGS, and I'm the person in charge to put a better image to EGS.
My name is Adrian Bersan. I'm the youngest member of the application team, and I came here to learn a lot of stuff, and EGS is the best place to do it.
My name is Mihai. I'm a buyer here for Eurogas Systems. I'm very proud to be a part of a great team here at EGS.
My name is Tiberiu. I'm a design engineer at Eurogas Systems. My job here consists in designing and calculating compressor packages.
Hello, my name is Norbert Kotpadi. I'm a project manager here at EGS. The job is challenging because we have to meet all the needs, all the requirements, but in that way it's also positive because it gives the opportunity to develop all the time and develop ourselves and develop our customer, basically everything.
I love my job, and EGS is a great place to work.
What I most like about EGS, besides the team that I'm working with, is that it offers me opportunity to travel.
EGS was a great opportunity for me, and I enjoy very much working here with all the team from EGS.
I enjoy working in EGS team. I like all the colleagues.
High quality of people. Basically, it's a great place to work at.